actually the original inventor of the chemical microencapsulation technology in the 50s. And we have a lot of patents, like over 70 patents, and many trade secrets. And every year we ship over 40,000 microcapsules globally. In fact, we've been doing very well, and we attracted quite a lot of investors. In 2015, a group of private investors called the Sherman Capital, they acquired us from our parent company. I was Appian, so they acquired the whole group. We came with this, and ever since then we've been growing very fast. So today, what we want to talk about is phase change material. We call it PCM. Do you know what PCM is? Phase change material. Okay. Simply speaking, PCM is a substance that can absorb or release a large amount of energy through melting or solidifying at a certain temperature. That's how PCM works. And why does PCM need to be encapsulated? Think about coconut oil. Okay, in the summer, in room temperature, the coconut oil is in a liquid phase. But in the winter, at home, the coconut oil becomes solid. So this nature of PCM makes it very difficult to work with other chemicals or the formulation. For example, you actually can't use the neat PCM in polyo because it's going to collapse the foam cell. So you have to encapsulate it. Even essentially, when you encapsulate it, you wrap a shell around this PCM. So the phase change nature, changing from solid to liquid, back to solid, it all occurs in this shell. And outside of the shell, it's inert, inactive. Because of that, you can use it in many different formulations. Because whatever happens resides inside the capsule. So that's why PCM, you almost can't use it without encapsulating it. Okay, so how would we put the PCM in the foam or on the foam? There are basically two ways. One, you can put the PCM dried powder. You can mix it with polyol. Just use a regular mixer and then add isocyanate. So that way the PCM is in the foam, throughout the foam. Another way, after the foam is made, you can coat the PCM onto the foam. So both ways are good. So now we're going to show you a product demo. We're going to ask you to actually sit on a cushion, and you can tell us how you feel. Okay? Actually, we'll do this one. We'll do this cushion, yeah, because we can't see it. Okay.
We have a plan.
Yeah, we'll do that. So, do I have any volunteers? Come on, any volunteers? You're going to get a little present.
Oh, okay.
Okay. Well, all right. Any volunteers? All right. Okay, good. So, please feel free to sit on the cushion. And then you can tell us how you feel after a while. Oh, that's good. This is about consumer comfort. So basically, right now, PCM is used a lot in bedding products and foam beds. People use a lot. People like to have foam bed, but one of the top problems is sleep hot. After they sleep on that for a while, it's too hot. When you are too hot, you actually wake up. So next time when you wake up, and try to see if it's because you're too hot. Your legs and arms get out of the blanket, and sometimes you literally have sweat over there, right? So how are you feeling? Yeah, both sides, and they feel the same or different?
I think the left side. Yeah, you know, it feels colder in this side on the left.
Okay. What they're saying is that on the left-hand side, they feel colder, and on the right-hand side, not so cool. I wonder why, left side. This is why we picked the same person, because we figured, the same person, you have the same temperature, right, on both cheeks. So that's the most objective. All right. So still feel that way?
Yeah.
All right. Good. Thank you very much.
That's all?
That's all. Yeah. That's pretty easy. See, it's not really scary. Okay. The reason that they feel cool on the left-hand side is because that left-hand side, it has PCM. And they were only sitting on that for probably a minute or two, and they felt the difference already. Just think, when you're sleeping on the same bed or sitting in a car, for a long time, you really are going to feel the difference. So PCM, this is, sometimes you think, the gel or whatever, it's like a marketing gimmick. This one actually is not, because we have the scientific equipment. It's called the DSC. And when we do the thermal cycle, you actually can see a peak. Peak means like how much energy it absorbs. And then, so for those little capsules, we actually run the thermal cycle. We do a pretty stringent test on that. So we heat up the PCM to 50 degrees Celsius, and then cool it down to negative 10 degrees Celsius, and back up. Right now, our little PCM, they all survived 10,000 cycles, and nothing happens to them. So that means that, just think if one night is a cycle. Well, even though one night the temperature will never get down to negative 10, and it will never, move up to positive 50 degrees Celsius. But still, if you think about that, the PCM can do, as of now, it's still going. And really, that means 27 years. So it can last for a long time. And we have some other things, for people to test afterwards. Do you have any other questions?
So that sample right there is incorporated into the foam?
That one is coated on the foam.
It's coating, it's not incorporated?
It's not, but incorporated in the foam, it's about the same.
Okay,
so yeah, the only trigger of PCM is temperature. Once the temperature gets to 28, it starts to absorb the heat. 28 Celsius. 28 Celsius is equal to 82.4 Fahrenheit. Right. So maybe we should have some other foam product for people to test.
Mm-hmm. Yeah, we could even.
Yeah. Well, we have some foam, some product for you to test and feel, and then they have tested quite a lot. Yeah. So do you have any other questions? Any questions?
Jay, you mentioned the 28 melting point. Do you have other temperatures?
We do. We have 24, that's Celsius, and 35. And basically, sometimes we heard in the battery and in some other applications, they want a higher temperature. Like once somebody makes a smartphone, called and saying they want the temperature to be 50 degrees Celsius, we can do that. It's the same principle. People can pick different melting point.